Welcome to the second module of gravitation. In this module, we are going to study about the universal law of gravitation and its importance. Gravitation force is the force between any two objects with non-zero mass and separated by a distance. So, apple fall towards the earth or earth move towards the apple, or do both move towards each other? Actually, simple logic. This is the earth and the apple. Based on what we have learnt about gravitation, both apply an equal force to attract the other object towards itself. So, if the forces are equal, which one would accelerate more? Based on Newton's second law, we have studied force as a product of mass and acceleration. So, acceleration is equal to force by mass. That is, acceleration is inversely proportional to mass. So, if mass is more, acceleration will be less. As the mass of the earth is much more than the mass of the apple, it is the apple that accelerates towards the earth and not the earth. Now, how can we measure this force? To understand this, we need to know what is universal law of gravitation. What is universal law of gravitation? Consider two objects A and B separated by a distance d. The distance between the center is considered to be the distance between the objects. If mass of object A is m1 and mass of object B is m2, as the object A is bigger, we can take m1 is greater than m2. The universal law of gravitation says that every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That is, force is proportional to product of masses m1, m2, and force is inversely proportional to distance square, d square. Combining these two, you will get force proportional to m1, m2 by d square. So, as the product of masses increases, force increases, and as the distance increases, force decreases. So, by removing the proportionality sign, you will get F is equal to G m1 m2 by d square, where G is called the gravitational constant, universal gravitational constant. So, we can write G as Fd square by m1 into m2 by rearranging the formula. Now, let us find out who was the scientist who discovered the value of G. He was Lord Henry Cavendish, using a torsion balance, and found out the value to be 6.673 into 10 raised to minus 11. And what will be the unit? Newton meter square divided by kilogram square. It is obtained from the expression for G. So, G is equal to 6.673 into 10 raised to minus 11 Newton meter square kilogram raised to minus 2. Now, let us see what is the importance of universal law of gravitation. It would be helpful in knowing many of the natural phenomena which were believed to be unconnected. Motion of planets around the earth, force that binds the earth, motion of moon around, formation of tides, etc. So, we have studied what is universal law of gravitation and its importance in this module. Thank you.